Good morning, everybody, and welcome back from your break. I'm Navneet Meschiani. I'm the chair for the panel that will begin here in just a minute. Very pleased to have Ms. Marilee Wheaton join us again this year to be our panel moderator for our panel of experts here. She is the Systems Engineering Fellow at the Aerospace Corporation, also former Executive Director and General Manager of the Aerospace Institute, which is the corporate university. She's also served as the General Manager for 2 engineering divisions at the Aerospace Corporation, and she's also a fellow of 3 professional societies, the AIAA, INCOSE, and SWE. She's been with GSAW from the very beginning, so we're very pleased to have her with us. Please join me in welcoming Ms. Marilee Wheaton.
Okay, yep, everyone can hear me now. Well, I'm very pleased to be here and be moderator for this STEAM panel of folks that we have. The plan today is I am going to introduce each of our panelists, and I'm going to ask them an opening question in which they'll make a statement, and then what we're going to do after we do that, one each, then we'll go to start with a few other questions that we have put together for our panelists, but we are still looking for questions from anyone here. You have the cards. The folks up here are collecting the cards, so they will be then bringing them up to me, and we definitely do want to hear what questions that you have for our panelists. So certainly feel free, as maybe as folks are thinking through their opening statements and talking, it might have you think of some other questions, so please jot them down and get them to our folks up here. So I'm going to start with Colonel Brian Bracey, who is the Chief Architect for Space and Missile Systems Center, Advanced Development, AD. And Colonel Bracey is the Chief Architect and Enterprise Ground Systems Program Manager for AD located at Los Angeles Air Force Base. You heard Mr. Fitzgerald give one of the keynotes yesterday, 2 days ago. Colonel Bracey is responsible for prototyping a common ground architecture to transition Air Force Space Command space systems. Operationally, he was involved with the DMSP, Flight 14 launch and early orbit checkout. He's also a member of the team that brought the Air Force's first offensive counterspace system, the counter communication system, through IOC, FOC, and IOT&E. He has served as DARPA's Service Chiefs Program Intern and also supported an Air Force Scientific Advisory Study Board on space survivability. Before he was in his current position in AD, he served as Chief of the Satellite Operations Branch within the Plans, Programs, Requirements, and Analysis Director at Headquarters Air Force Space Command, where his responsibilities include developing and coordinating Air Force Satellite Control Network and Enterprise Ground Services architecture development and capability requirements, preparation for Space Command, the Air and Joint Office, Office of Secretary of Defense, and the intelligence community. So quite a wide background in subject areas related to our conference here. So one of the main points that Mr. Fitzgerald made in his keynote talk was he talked about how he really believes that leading the way in this new space warfighting construct, or space enterprise vision, as was known, is really the enterprise ground systems. So what I wanted to ask Colonel Bracey is, given Mr. Fitzgerald's statement about enterprise ground systems really leading the way for this need, what do you feel are the key items or enablers that are allowing you to do that?
Okay. Thank you very much for inviting me and for the introduction. To double down on what Mr. Fitzgerald did as far as what EGS, Enterprise Ground Services, offers is, there's a number of things that are common across all the satellite systems that we fly today. But yesterday at the panel, talked with Nestor and some other folks, it's common across NASA, across the ESA, across pretty much everybody's struggling with those same types of problems, which is how do you make things more efficient and put your people in the right places that they need to be. So the things that are enabling us to move forward right now, it really comes down to the resource part of it, which is, do you have a team with the right talent and the right initiative, incentives, et cetera, and the ability for them to essentially knock down the walls to be able to develop that stuff and be able to move forward on that. That takes a lot of coordination, it takes a lot of collaboration, it takes a lot of messaging with different folks. I would say in our part right now, an advantage that something that we've seen as far as some of the culture change within SMC over the last year is, initially it was like, why? Why do I have to do EGS? What I've seen now from peers is not so much on the why question, it's the how. And then how long does that take, and how does it look at that point, and how much do we get into, and how do we get what it needs to be for EGS, and how do I understand that? So that's the messaging part of it. We've gotten to that point, so that's great. Now we've got a team that needs to deliver that core part of it that we've promised, and then we need to get essentially to contact, and the enemy is the wrong word, but get it into test, get someone putting their applications on it, to get to that iterative loop to understand now what is it that we knew, what assumptions we made were valid, what assumptions weren't valid, and then to be able to fix those going forward and be able to bring one system at a time on consistently again and again from now until the time the Air Force Space Command stops flying satellites. Make all those things common, put our operators in the right spots that they need to meet to do some of the things that General James talked about this morning, which is a fantastic vision. I mean, he's definitely a unique individual. 10 years ago, he was talking about that iPhone thing and driving people crazy, and now we're like, well, that's not so hard. Shouldn't we be able to do that? For our part of it, are we able to get to that really easily? No, we're not, because it's not a technology problem. It's a biology problem. And that's not picking on any one individual or any one organization, but it takes that many different people to align in the right places that own funds and control those spots to convince them that you're trying to help them solve their same problems and that we're all safer together working as an enterprise than you are if you do it by yourself. Because at some point, when that team goes to war, if you're on by yourself, you're vulnerable. You gain strength for being together. So how do you convince all those folks that we'll make you stronger by just listening to us, helping us iterate, and putting stuff onto an enterprise?
All right, thank you, Colonel Bracey. And we'll be coming back to the subject of enablers as well, too, in some of the questions, but wanted to start with that. Our next panelist is Dr. Azad Madni. He's professor and director of the System Architecting and Engineering program at the University of Southern California, Viterbi School of Engineering. He is also a professor by courtesy in USC Schools of Medicine and Education. Before he came to USC, he was the founder and chairman of Intelligent Systems Technology, which is a high-tech R&D company specializing in game-based educational simulations and methods, processes, and tools for complex systems engineering. He received all of his degrees, BS, MS, and PhD degrees from the University of California, Los Angeles, and his research for his company, ISTE, has been sponsored by a vast number of government organizations, DARPA, OSD, the Army, ONR, Air Force, OSR, Department of Homeland Security, DITRA, NIST, Department of Energy, and NASA. And also, in addition, aerospace and automotive companies as well now, such as Boeing, Northrop Grumman, Raytheon, and General Motors. And research has continued as he's been working at USC. He's an elected fellow of a number of organizations, the American Association for Advancement of Science, AIAA, IEEE, Life Fellow of the Institution for Electronics and Telecommunications Engineers, also a fellow of INCOSE, the System Engineering Organization, and also the Society for Design and Process Science. He serves on the USC's Council of the Center of Cyber-Physical Systems and Internet of Things, and he's also very involved with STEM. He's on the steering committee of the USC Provost STEM Consortium. So his research interests involve formal and probabilistic methods in systems engineering, model-based architecting and engineering, engineered resilient systems, cyber-physical systems, and exploiting disciplinary and technology convergence in systems engineering. And actually, this theme of disciplinary convergence is the theme for a conference. It's the 15th Annual Conference on Systems Engineering Research that he's a general chair of, along with Barry Boehm, who was here earlier this week. They're both general co-chairs for that conference, and research in systems engineering across all of these areas. So the question I have for Dr. Madni is, based on the current research that you're doing in these areas in terms of resilience and disciplinary convergence, what do you see are some of the really key trends related to that research that might be important in terms of the future for ground systems?
Well, I'm happy to be here, and I wanted to put in a plug for the Conference on Systems Engineering Research, which is
Mike.
just, yeah, happy to be here. Can you hear me? Yeah. No? So we have the Conference on Systems Engineering Research, next week in the Crown Plaza Hotel in Redondo Beach, and I hope to see some of you there. At least I think you'll enjoy it. It's a star-studded cast of people from defense, aerospace, space, and industry. It's an international audience as well. We have about 60% who will be local and 40% who will be international. The top students will be presenting their research, their doctoral research there, and I think you'll find this to be a special conference. I've been running it for about 10 years. Every third year, USC chairs that, along with INCOSE Los Angeles chapter, and I hope to see you there. Now, with respect to the focus on ground stations, or what envisioning the future, if you will, I have to tell you that I work on in three specific areas that bear on this. One of them is in the area of autonomous systems, and specifically in self-driving cars. I also work in the area of multi-UAV swarms from a system of systems perspective for both defense and civilian missions. And I work in the area of experiential design languages, the notion that when you just speak mathematics and black boxes and block diagrams, you leave a whole bunch of stakeholders out of the equation. And you come back and you pay the price for it later on because you stifled the communication from people who had a lot to say but couldn't say it because they didn't speak your language. And so the whole area of how do you create a way to get people involved early without imposing mathematics and block diagram language on them. So with that little backdrop, I would say that there are three specific areas that I find very exciting. And I think there's a convergence among them. The first is science fiction prototyping. The second is augmented reality. And the third is interactive storytelling. Now, you heard General James talk about augmented reality and virtual reality and stuff, but I want to kind of give you a little a teaser on each one of these to see how they, in fact, have synergy. Sci-fi prototyping, the term was coined by Brian David Johnson from Intel. And the whole idea there was to introduce a new technology or a new social concept, because every technology comes and revises how you interact with it. So the social concept is very important. And you can try these ideas in an evolving system design. So you don't use this prototyping as a way to try to forecast the future, but rather to create and explore alternate futures by extrapolating current trends in technology from research into practice and what that might look like down the line when you explore alternate futures. The whole idea behind this is that you use science fiction stories in the sense that things don't exist yet. So therefore, there's a science fiction part. But you ground them in reality as you expect it to be down the line. And so this kind of work can be done by anybody, by engineers, sociologists, business people. What you're talking about is a new piece of technology, stories wrapped around them, exercise in virtual worlds, and you try to see where the inflection points are. You see what the ramifications of science and technology is on people and what the unintended consequences that might result from them, because technology, new technology comes with new problems. Many of them are unintended consequences, and the whole idea of science fiction prototyping is to uncover as many of those as you can by test driving these ideas in a prototyping environment. The second is the notion of augmented reality, and this is a term that was coined by Tom Caudell of Boeing in 1990. The whole idea here is that the interaction of superimposed graphics, audio, and other enhancements over real-world environments that is displayed in real time. I mean, you see this, how important, how effective it is. When they show you in NFL, in the National Football League, that line that they put across to show how far you have to advance the ball to be able to make your first down. Simple things like that, that you overlay on reality, and it creates a much better experience. So the difference is in virtual reality, you're trying to replace reality with virtual worlds and simulations. In augmented reality, you're trying to enhance reality so you can make a better job of communicating what's going on. So what has happened is in recent times, augmented reality has become a very effective social media tool for sharing experiences on the internet. And when you can wrap these things in terms of interactive stories, you make for a very compelling experience. So imagine telling the stories of future missions, of future technologies that might be employed in a ground station by combining the power of science fiction prototyping, augmented reality, with interactive storytelling. Now, interactive storytelling is another very important area. I've been working in it for a dozen years. And the whole idea here is that you create partially scripted stories that you instantiate in a virtual world. And then you allow the different stakeholders, potential, and including users, to interact with those stories and explore alternate futures. Every one of them sees the future from their own perspective. And you bring that together to bear in a collaborative environment, the way our keynote speaker, General James, talked about. And now you've got something. Because not only are you exploring a future from different perspectives, but you're sharing those perspectives while you're still in the early stages of design. And this can prevent a lot of regret and redesign and iterations and things of that nature. So the whole concept here is that we have technology that has already converged, and we see that in our iPhones. Now you're seeing convergence among disciplines. And the specific convergence that I see, that I'm talking about here with these examples, is the convergence between engineering and the entertainment or cinematic arts. I think that convergence is going to reach a wider stakeholder audience. I think it's going to allow us to better understand and explore alternate futures. I think it's going to have a bigger impact on us understanding unintended consequences. And I think ultimately it's going to save extraneous design iterations and rework. So that's basically where I come from. That's where my research is going. That's where some of my students who are doing their doctorate with me are working on at USC. And I'll stop here and I'll take any questions down the line.
Thank you. Our next panelist is Nestor Petsia, and you have heard him earlier this week. He's the head of the Data Systems Infrastructure Division, Department of Engineering at the Operations Center of the European Space Agency in Darmstadt, Germany. He's also chair of the CCSDS Engineering Steering Group, and as you know, ESA and the Europeans are very much leaders in the standards world and utilizing CCSDS. He's also chairman of the European Technology Harmonization on Space Ground Software Systems. And harmonization is, more than just a word. It's, actions that are definitely taken by our European colleagues and partners. And he's also the ESA Technology Competence Domain Leader on Ground Systems and Mission Operations. So you saw who got best paper this morning. It was the group from Raytheon that talked about ground station of 2037, and they talked about future trends, 5 trends that they saw driving space ground systems. But what I'd like to ask Nestor is, from his perspective and thinking about it from the collaboration that they do in Europe, what does he see as some current future trends related to collaboration and innovation that he can talk about?
So thank you very much for the invitation as a panel member. In order to have a better understanding by US citizens, and just that we are in LA and close to Hollywood, that is the leader in science fiction movies, I will try to use the European example in USA. So imagine that the US government gives to me the power, command-in-chief, for infrastructure for monitoring and control systems. The first thing that needs to be done is to get together all the stakeholders. And I mean not only US Air Force, I mean 5 or 6 centers of NASA that are developing sometimes different type of systems. NOAA, that we have a panelist here. I will invite Loral. I will invite Boeing, Northrop. I will invite SpaceX, because you know that to monitor a launcher, you use the same functionality that to monitor a satellite. I will invite as well other partners that I am not aware. And the first thing that needs to be done is to get everybody in a culture of collaboration. And for that, an MOU needs to be signed to develop something that could be used by everybody for everything that is monitoring and control of space assets. You need to sign as well a collaboration agreement where the stakeholders, maximum authorities, are committed with resources to support this venue. I will say we use open source community software. We will as well write the licenses, how to license this software, and how the software will be maintained in the future by an agent. All this took us in Europe 4 years to do. Which are the enablers? The culture to collaborate, the commitment of the maximum authorities is not the head of department or the head of section or the head of division. This MOU needs to be signed by the administrators, by the CEOs of the industry, and the other thing that I will do is not sequestration. I steal the budget of all the stakeholders, and I give everyone 5% to maintain and evolve their current systems. And this means immediately, I don't have the money, I need to collaborate. And of course, which are the inhibitors? Risk aversion, reluctance to change, feeling of ownership. Take this as a family. Everybody wants to protect a real family. But if I have a virtual family, I don't need to protect anything because it's virtual. When you go from real systems in hardware and software, and you tell the guys, no, now will be virtual, open source, and you use it, there is a feeling of ownership that sometimes acts in a negative issue to this type of initiatives. Of course, the inhibitors are fatty budget. This is why we need to cut it. And the other important thing that needs to be understood, at some point you freeze the technology. To develop this type of systems, you cannot innovate in technology when you have a 3-4 years implementation of a system like this that is a complex system of system, and you innovate after the system has been delivered, integrated, verified, validated, and then you start to evolve that. So I hope you have understood the message.
Thank you. That's definitely a great Hollywood story from a ground systems perspective, and the fact that it's true in Europe makes it even more compelling. Our next panelist is Steve Peterson. He's the director of the Office of Satellite Ground Services for the National Environmental Satellite Data and Information Service, NESDIS, for, of course, the National Oceanic and Atmospheric Administration, NOAA. Mr. Peterson is a member of the Senior Executive Service, serving as director of Satellite Ground Services. The NDIS systems provide support for the GSAW and JPSS ground system development and develops and migrates existing and future ground capabilities to an integrated service-based enterprise. Before he joined NESDIS, Steve served as the Defense Intelligence Senior Leader assigned to the Chief Technologist, Advanced Systems and Technology Directorates in the NRO. So a good transfer of skills there from one agency to another. He provided technical oversight of the Directorate's information technology portfolio and led initiatives to identify new sources and methods, accelerate the pace of technology development, and reduce transition time. Mr. Peterson organized and led 2 groups to develop new products and services based on data collected by the satellites. After 29 years of commissioned service, Steve retired from the Air Force in 2006 with the rank of colonel, and in his active duty career, he held positions in research and development. In addition, he flew on HH-53 and C-130 platforms as a flight test engineer, developing equipment used in the aerial recovery of deorbited satellites. He also organized and directed many space technology development programs, serving with the Space Division, Air Force Space Technology Center, BMDO, and the Air Force Research Laboratory, AFRL, and the National Reconnaissance Office. He led the transition of launch warning technology to the first operational system, which was fielded by BIMDO, the ALERT Theater Missile Defense Program at Schriever Air Force Base. So, Steve, given your previous experience in terms of with IT and being the chief technologist, we know that IT plays a very important role related to technology for ground systems. So could you comment on what you really see are the innovation needs in IT that will be necessary for future success for common ground systems?
Yes. Is that working? You're on. Okay. So thank you very much for the invite and a wonderful introduction. So in our realm, we really are highly dependent on IT, certainly. And one of the things we've come to realize over the last couple of years, and I think probably many of you have realized it as well, is that technology is accelerating. Things aren't just changing, but they're changing faster and faster than they used to. And so there's really a premium on being flexible and being agile, being able to get outside your own processes sometimes to take advantage of new opportunities. So in Nestis, we've just launched a new satellite, the new GSAW constellation, which is great advances, and we're on the cusp of launching JPS here in the future, which is a similar step forward in the polar realm. And so as we get ready to host those and sustain them and maintain them, we look at all we have to do and the opportunities. We're really struck by the fact that while the sensors are cool, and we're going to continue to build and fly new sensors, the real action is on the ground. Okay, and our ability to show value in the future is going to be a function of our ability to harness and apply the new IT technologies, many of which are coming from the commercial world. And so of course there's a counterpart to that on the pure space side. As access gets much cheaper, many more people are using space for different purposes, and they're actually starting to compete with the government sector in ways that would have been impossible just a few years ago. So in the IT sector, there's this whole Silicon Valley world that's driving forward. You've heard a bunch about that in the last couple of days, applications of cloud, containers, using virtualization maybe in ways that were different. So as we look forward, I believe IT is both the key to our future relevance, and we're also kind of being held hostage to it if we don't find ways to get out of our traditional approaches. So for example, the sustainment of the systems, which is one of the things my organization does. In a few years we're going to have to refresh all the hardware with those big new ground segments that are coming to us now with the new launches. Do that the old way, it's enormously expensive, and it takes a lot of time, and it's very, very disruptive to ongoing operations. So just simple things like looking at, can you use IT trailers or IT containers to do those refreshes, right? Commercial industry's been doing that for about 20 years. And there are actually cities up in the Northwest where the power is very inexpensive, cities that are built based on buildings that are full of trailers. And that's pretty much all they have there are the trailers. They can be operated remotely. They don't require a lot of maintenance. And when there's a new generation of IT, you just unplug the old trailer and plug in the new one. It's literally that easy. You don't have to do what we would have called months and months of MILCON, right, back in my Air Force days, where you'd have to get the money 3 or 4 years ahead from Congress, and then it would take a year or two to pull out all the old cables, relabel the new ones, all that stuff. That's the old way of doing it. And so we need to find ways to be much, much more agile than that and give ourselves the freedom to exploit the advances that are making it much more economical to do if you do it a different way. And I thought the talks over the last couple of days about moving entire operating capabilities into a cloud, perhaps somebody else's cloud. If you stayed last night and listened to the architecture folks that gave an overview of some of the NOAA architecture work that my team has led over the last couple of years, there are insights like the ability to maintain and refresh a capability for the big cloud providers. They seem to have found a way to manage many more servers with a single admin. They seem to have found a way to do the security hygiene a lot more effectively than we might otherwise do it. So in the future, our ability to exploit those things is really going to be key to our survival and our relevance. And on the positive side, some of the new technologies for fusing, manipulating, distributing, reprocessing data are opening entire new opportunities as well. And as the GSAW data starts flowing operationally here in a few weeks, people are going to start to figure out applications for it that they could not have imagined before it went up. And then which means the people in this room, are going to be key to enabling that, right? Making it possible to use those greater and greater volumes to do really cool things that you couldn't do before just because you didn't have the power, you didn't have the bandwidth or whatever. So we need to be flexible and agile and think forward and adopt the processes that allow us to do those things. Thank you.
Thanks, Steve. Our next panelist is Stig Thrana. He's the head of the Kongsberg Silicon Valley. He's the U.S. Sales Director for Satellite Ground Systems for Kongsberg Defense Systems. So in this area, he is he's one of the entrepreneurs and pioneers in the KSAT Light Network, which is the world's largest new space network. Kongsberg Satellite Services, KSAT, is a world-leading provider of ground station services for LEO satellites, thanks to the company's uniquely positioned global ground network, especially where they're located in Norway, in very northern areas. He holds a bachelor's degree in entrepreneurship and innovation very aligned with our theme, and has been working with professional radio and satellite communications for more than 10 years. Steve Isakowitz, in his keynote, talked about how he feels that inertia is the polar opposite of innovation, especially with change being the new norm. So I'd like to ask Stig, what he sees, coming from the commercial environment and kind of the new space. What are some of the enablers that he is seeing that allows them to serve this broad families of satellites through their services?
Thank you. Pleasure to be here among these great panelists. Yeah, in GSAW we started, we actually have a 50-year anniversary in this field just about these days. Back in Norway they're having a huge party, but I'm very glad to be here with all of you. So actually the really starting point for KSAT back in the days was we deployed the first system up in Svalbard at 78 degrees north. We did that to support a sounding rocket mission for NASA. And since then, the station has been populated with more than 50 antenna systems. In 2007, we also went down to Antarctica to deploy a station there. And since then, we've put in more than 20 locations around the world. So in terms of having a total global architecture from a ground station, it's been a tremendous journey for our company. So and then I think approximately 4 years ago we started working with some of the commercial companies here in California particularly, and they had a completely different approach to challenging the status quo. So for us as an organization, we said, where will this take us? We were uncertain. We're supporting, our government missions, agencies. About 50% of our revenue comes from the U.S. And we said, well, let's do this as an R&D project. We have nothing to lose on it, and the input that we will get will help us in challenging how we do the architecture. So we said our knowledge is our greatest advantage and our greatest disadvantage in this, and we need to have these new commercial players challenge us in the way we do things today. So with that, we started what was called, we called a KSAT Light network. It was a deployment of 3.7 meter antenna systems in X and S band. And our goal was really to, instead of doing the architecture as an output, as a requirements list, we thought about having people coming to us and adapting a network that we would build. And I think it's been really intriguing. We're now seeing the sort of outcome of how we approach this, and people coming to us and say, well, how can I adapt to your network from a best commercial standpoint? How can I achieve and use your platform and your global network? How do we interface and how do we operate in those terms, instead of having people to come to us and tailor make it based on their requirements and specification. And I think finding ourselves with satellite owners working with satellites in any size or functionality, I think our sort of next phase is to see how can we adapt this into enabling the next generation of satellite systems. And I think being an enabler in between the vendors and the government and tying together and unleashing new capabilities, if it's bandwidth, if it's new technology, cloud systems. So I think in that sort of lane, really trying to also help get the information and the end users that are using this data what do they need in terms of ground architecture, and how does the ground architecture emphasize that, if it's from a near real-time perspective, or if it's from just unloading a whole lot of data and using it from an archive standpoint. Like you mentioned here, is there's a complete change in so many parts of the value chains that we're trying to integrate and work more closely with.
So as you can see, we have a great wealth of talent here on our panel, comprising some very innovative current and future visions of what ground services and common services should be. One of the areas that always comes up is, technology, is out there, but usually that ends up not to be the primary barrier, right? So it usually is in other areas. Specifically, and certainly it happens here in the U.S. a lot, it's related to the acquisition process that we use to procure the services that they want in ground systems. So the idea is, how can the acquisition process be updated to be more agile? And it's certainly on the minds of our attendees here as well, too, where the comment is technology is not the issue preventing progress in ground system architectures. The acquisition system and process is. And so the question is, and this one is directed first to Air Force and to NOAA, in terms of things doing to change the paradigm, especially potentially in light of the current regulations related to acquiring systems, DoD 5000.02, which came out in 2012. So are there things that are being done, potentially also in the area of collaboration between NOAA, Air Force, NASA in the areas of satellite and ground system acquisition? So would you like to start with that, Colonel Bracey?
Yep, sure. All right, button pushed. All right. When you actually start looking at 5002 and the stuff, the authorities and regulations that are out there, that's just one document. Every individual community, whether it's contracting, financial management, legal, has their own set of documents that they're beholden to. What I'm firmly convinced now is it's not so much that process that causes us the problem as it is the actual culture within the institutions that execute the acquisition. If you show me, I'll say, 3 levels of leadership that will agree on and allow organizations to go fast, in a contracting office that is designed to essentially make the mission happen versus avoid protests, you've got everything that you need to be a rapid acquisition organization. All right. Anything else you've got that falls to the side at that point. How do you make that happen? As far as how to make it better, at this point, I've got 22 years of experience. I think some of you in the audience are more so on Karen's half-life of what your career is. The number of times we've done, how do we reform acquisition and do X and Y and Z? I've yet to see anyone that's actually found that sweet spot that makes it happen, which is why I'm firmly convinced it's the culture part of it. I'll make a brief analogy because I like it. I don't know how many swimmers or triathlon people are out there, but I know most of you watch the Olympics, okay? So in the Olympics and the swimming events, those people sit down. Those events are scaled to make people go as fast as possible, all right? The water is a perfect temperature. The lanes are clearly defined, and they get there and they have one objective to get there. In the acquisition, or what we do in the DoD as far as how that gets put together across all the functional communities, I consider it to be more open water swimming, like a triathlon. If you ever go Google a triathlon for a start, and there's some pretty funny ones out there, because you got 100, 200 people. They all have the same objective. They all want to go as fast as possible from spot they're starting at to the next spot to do transition. However, it's a little bit different because it turns into a scrum, and people are walking out of there with black eyes, scratches, thrash, because people are on top of each other the entire time. And that's kind of how I see the acquisition process as it happens right now. Everybody's got the same objective, wants to go fast, but no one really cooperates that well. You're not going to see an open water swimming event where people are lined up right behind each other to get to that same spot. This is not going to happen, okay? So then how do you have to find those that win, okay, figure their way around it, what their strengths are. Maybe you start a little bit late. You start more to the outside. You find the holes in the system that allow you to move faster than just jumping in there with everybody else. And that takes a culture and people that are looking for those things to make it happen.
Steve?
Yeah, so I'd like to add to that. So in my experience, it's really an issue more of leadership than management. And there are a couple areas, I think, where we already know how to do this, we just don't always have the wherewithal to do it. So I think it really starts with understanding what you're trying to accomplish. So I've seen some programs where the leaders really, at a technical level, they understood what the issues were, what the challenges were, and they understood how to track progress and the resources they needed. They were able to build teams to do that. So I think that's really key. I know Gary Payton used to say, no program can be better than its customer, right? So if the customer doesn't really understand what they're trying to accomplish, they're probably not going to be all that successful. The second thing is working collaboratively with your contractor. So I had one experience in a prior life where one of our subject matter experts on our team, who was a civil servant, actually took the time to learn how a specific technology and a specific set of subsystems worked. And then he recognized how the threat was going to change and what we needed to do different for the next series of that constellation. So then he was able to partner with the contractors who were willing to take risk and lean forward and do new things as long as they knew that inside the government there was someone that could explain it. So they wouldn't get lit up for leaning too far forward compared to their peers. So over time, they made enormous changes that is still having an impact today, and they did it because the team understood what it was trying to accomplish, and it was able to work hand in hand with the contractor, maintaining the proprieties that you have to be aware of, but working as a team to achieve common goals, making trade-offs together, adjudicating risk judgments together, and they were very successful. And the last piece of that with the acquisition part, I think, is getting the same degree of support and excellence on the government side. So when I was in Chantilly, my contracting officer had an office right next to mine. Now, she reported through a different chain of command. We had the separation of the roles that you have to have. But when we needed something, it was only 10 or 15 feet walk to communicate about it. And her buyers and specialists sat right next to her. And my program manager sat right down the hall from me. So when we needed to get something done, we would just do it because we understood how to do it, and we had the full support of people that were every bit as dedicated to the mission and had their own excellence, their own knowledge of how to get things done. So in my mind, in all three cases, it really relates to leadership. It's not more management process. It's understanding what you need to do and having the wherewithal to summon the resources to get it done.
Thanks, Steve. I'd like to add an add-on question. Given that we talked about that it's culture and leadership, a lot of that starts with how we educate folks as they're coming through. So Professor Modney, any ideas from the university domain in terms of education and some future thoughts about how we can position ourselves for success in terms of people coming out of the universities?
I think all these things are really technology, process, culture, and leadership. These things are all interrelated. You cannot just teach one in the absence of the other. Because any place you poke, it wiggles everywhere else in those things. So I think it's very important. And this is why, coming from a systems background, we teach systems thinking. We don't try to presuppose what the problem is. We don't presuppose it's a process problem or it's a technology problem, it's a culture problem. We essentially try to formulate and frame the problem and then try to figure out what it is, because the problem that typically we have as humans is we tend to dumb down the problem to fit a technique or a method that we have in mind, rather than try to understand the problem at scale and try to scale up our methods to fit the problem. And that's what system thinking is all about. So what you'll find is there is going to be an interplay between process and technology and culture and leadership. And you can't leave any of these things out because these things are highly correlated and coupled. The way you deploy one technology platform in one country of one culture is very different than the way it would be in a different country, a different culture. You see that with aircraft. You see that with automobiles. So I think it's very important to really teach a more holistic perspective rather than carve up these silos and teach silos, because I think that those days are gone. We have to teach across thematic disciplines as opposed to a single discipline.
Yeah, thank you. I'd like to hear from our European colleagues in terms of, obviously a lot of this collaboration and common and, have been supported by certain acquisition processes. So would either Nestor or Stig like to comment in terms of things you felt are enablers from your acquisition process that have allowed you to be successful? and or if there's still some barriers that you're still trying to work on?
Well, when considering software acquisition, when we are going out to the industry for implementation of our systems, what we have, first of all, and I am speaking at the European Space Agency level, is what we call a frame contract that is a closed club of industry that we know are able to deliver our systems. And the request for proposal goes only to these contractors. And what we are doing is imposing certain aspects of the acquisition, enforcement of standards, compulsory use of our infrastructure. We don't give the price tag of the software development implementation product. This is why yesterday I show as a question, can we get software turnkey systems from start until 6 months before launch for 300,000 euros? Well, we are able. Can we get electrical ground support equipment, hardware turnkey for a satellite manufacturer on 500,000 euros, 500,000? We are there. So there are certain things in the acquisition that are paradigms that we are not changing since more than 25, 30 years, and all the industry knows how to do. Why they can give us this type of low prices is because for them it's a very good selling policy for external customers to develop for ESA and to use the open source or community software from ESA. And you can see very well how is in our convention. We need to ensure the competitiveness of the industry, European industry, at worldwide level. This is in our convention, and this is what we are trying to do since ESA creation. And a company like GMB that is mastering high flight, that is based in our ESA software, 30 years ago when I started in ESA, there were 15 persons as experts in mission analysis, flight dynamics, and navigation. Today is the world leader in provision of mission control systems, not only for the telecommunication arena, but for the institutional. So our acquisition as well had this in mind. We create a critical mass in Europe to compete in the world, and all these rules are inherent in our procedures when we go out for acquisition.
Okay. Stig, any?
I think you're right, Nestor. I think it's but like we have a traditional way of working and you know, challenging that sort of situation. I think, you know, the ground system has I think been sort of left out of the whole process of the design chain. I think it's in many outcomes it has the mission design has as a requirement for the ground systems, but not including the ground ops. I think more and more companies and government now are looking towards, you know, really including the ConOps at an earlier perspective than what they used to do. And I think also how we look at the ConOps perspective is quite different from a ground perspective. Think of we went out for deployment of ground system at a particular location to support any type of mission. Of course, for some application makes perfect sense, but for other applications, why not see the whole network as a whole? Why are you reliant on that one particular geographic location? Can you acquire your system from a total global network? And in terms of you know, the buzzword that's been talking about for many years in resiliency, that makes perfect sense. You know, and in terms of the data and the information that you need to acquire, it can create a whole different value set than doing it from a particular location. So I think, you know, looking at the whole chain of it, it's you know, integrating the ConOps and what do we need from a ground architecture to really assure the goal and the information that we're trying to give to the end user or our organization.
Stig, I'd like to ask a follow-up question. You know, you're talking about having people adapting to your network versus trying to do custom, and there was a question related to whether your APIs interfaces are standard-based, and you know, whether that has been part of your success in building this ground architecture framework, and if there are other key things related to being able to do that. You might mention about that?
Yeah, I think the API or the architecture that we build up, for the KSAT Lite network, that's the approach that we tried to design. Even though it has a whole degree of flexibility, I think, you know, the forgotten word in today, which nobody talks about today, is interoperability. So that's extremely important, I think. So today we do approximately 27,000 satellite contacts each month, and it's growing significantly year by year. And you know, we operate a global base of customers from, you know, ESA, it's NOAA, USGS, it's JAXA, it's commercial companies throughout the world. So I think in terms of having the API, it's even though it's standardized, it has a high degree of flexibility. And I think having this powerful platform scheduling routine is key in this operation, as we see the satellite population is growing. So it's having a good logistical system that can operate all of this.
Thanks. We know in today's rapidly changing technology and business environment that there are a lot of new stakeholders and players. We certainly see them in the new space environment. So I was kind of wondering about new stakeholders and players involved in ground systems and how we're going to incorporate them. And specifically, we got a question, I'll start with you, Colonel Bracey, that how do you envision integrating commercial assets and service providers into EGS?
As much and as fast as possible within my control. So, part of what EGS is going after is essentially to establish an ecosystem that we provide a baseline infrastructure set of standards that everybody can build to, and that's well understood. What we found from a lot of the commercial folks that we talked with is if you provide me a standard, I'll build to it. But if you don't, I'm going to create my own, because this is something that I have to execute to actually deliver my particular product. So once you establish what that baseline is, you've got to have a funding source. You've got a way for the operators to get requirements to you. And you need to have a development place where those commercial providers can bring that application, wherever their service is, into it to test it, to have the operators go, yeah, I want that, and then get it on the floor as soon as possible. So EGS provides that initial steps to create that ecosystem that acquisition has to establish, and then essentially get the trust from the operators to go, look, if you need some type of capability, you're on the floor and you couldn't do some sort of action, how do you solve that problem? How do we give you something that can give you a solution versus just identifying a bunch of problems? So that operator brings it off of the floor and goes, hey, I need something that can look at all the satellites in GEO and what the thermal temperatures are on the solar arrays right now and tell me over the last 24 hours, are they healthy or not? Are they at threat or not? And something needs to pop up in front of me that says if that's bad or not. Okay, well, you have to have an environment that you have to have a contract vehicle to get folks on contract to put out some sort of BAA or notification that says, hey, do you have a solution for this? And whether you've got a pre-made solution that's already there that you're working on for NASA or ESA or something, or you've got some developers that are like, hey, I can get after that. How do you provide that economic environment for them to put that thing together, bring it into the floor, show what it can do, do some quick tech evals, get the operators in and go, yeah, that's the one. And then I could do it without suffering a 3-month protest, okay, because someone else thinks theirs is a little bit different based on whatever the actual thing was sent out there. Okay, we need it on the floor like within 120 days, okay, or less to respond to the threat environment. Not in 6 months, a year, or 2 years. Anyway, so that's how we envision trying to bring them in, is starting to create that ecosystem that allows those things to happen, to bring in applications responsive to the threat.
Okay, thank you. Any other folks like to comment on new stakeholders and players that they see potentially be involved in ground systems and how they would be? Steve?
Sure, we've been looking at that hard as the commercial world starts to offer weather-related capabilities. So really, we're doing a couple things. With our architecture work, we've been focusing on common services and solutions, and then adopting an architecture that anticipates the need to interact with different communities. And we're doing that really on both ends of the data flow now. In terms of the bringing in the data, we recognize there are going to be a number of new players whose data we will want to consume and build products from and then pass to the models. So we're looking at a ingest capability that's much more flexible than what we currently have, and it also has security provisions that allow us to bring in a very wide variety of sources. So making the enterprise available to a broader group. And then the other part is on the dissemination of the data. We've got some CRADAs going with a number of industry partners where the question was, can we work together to find a way where we can make all of the NOAA collected observation data available to the partners. The partners, or industry partners, distribute it to the general public for free, meaning you can download anything you wish on your computer, but it'll be just the raw data, right? The data that we already make available as part of a public good, part of our role in the government. And then by virtue of doing that, they have the ability to build value-added products that they can then sell and try to monetize their investment. So that's a fairly new way of looking at how we can provide the nation more value from the data. So we're looking at both ends of it, both the common services part and then the looking at how we can better link directly to the shareholders.
Sure.
All right, ask her for a quick go back. Okay, another part with the commercial stuff. So right now we've got 5 standards working groups that are set up, and I think a number of the people in the audience are supporting those. So that's us trying to reach out to the commercial folks as well to go, as we define these standards, we don't want these government-owned, that we decided what the standard is and thou shalt abide by it. What's the best that commercial has? You guys know that better than we do. So that's why I've got the working group stood up to identify what those are, for us to capture them and go, it's not government owned, it's not government created, it's enforced based on what the commercial guys can actually build to. So I just want to say thanks for those that are participating in those standards working groups that are helping us get to that point where we establish that baseline that's well understood and you've essentially defined what you're going to build to before you even actually got the requirement to build to it.
Yeah, and I'd like to add, I'd like to say thank you, Brian, for standing that up and for including us, as we realize that if on the government side, if we can have our act together and present a consistent face to industry, then it's going to be much easier for you to work with all of us. So we strongly support that and are really excited about participating.
Thank you. We had a question here related to humans in the loop. And so I'd like to address this, start with to Dr. Modney. So the question is, how do we keep humans effectively in the loop for evolving ground systems? With technology advancing so rapidly, how do we keep humans from being engulfed by the technology while still being fully involved in ground system operations? So in other words, how do we upgrade the human without technology? What's that balance there? So Dr. Modney.
This is a tough problem and has been in everything that I know of where you have humans in the loop, whether it be in a supervisory control sense or lower levels of control. Because the challenge that you have is what you really want is to maximize the human's ability to adapt without saturating the human's capacity to adapt. And that's the key. If you have a human in a loop, you have to have a certain rate of stimulus to keep the person's vigilance and state of arousal at a level where they can be performing at peak. If the arrival rate of stimulus is too low, vigilance drops and humans tend to miss. On the other hand, if the stimulus is very high density and humans cannot keep up with it, then what happens is they start missing things and performance drops again. So you have this inverted U-curve, what's called the Yerkes-Dobson law, that governs that relationship. Now, when we talk about adaptive systems, things become much more difficult because the system cannot adapt any faster than the human can. And that's the key here. And the human's ability to adapt is very much a function of the type of adaptation called for. And so that makes it very, very difficult. So what you have to do is, depending on whether something is safety critical or mission critical, you have to, if lives are not at stake, then you can say, we will set an upper bound of error rate that we can accept and then maximize the adaptation rate. That does not work if you have essentially a zero fatality situation. So I think this is a very, very tough problem. And the other thing is that as people adapt, as the system changes modes and changes states, the human has to stay cognitively coupled to know what state the system is in, what mode the system is in. Otherwise, what you have is a miscommunication between the human and the system, and the incidence of errors goes up again. And then the final thing I would like to say is that depending on whether the human is going to intervene in a machine process or not is a very important thing. If you have a system which is completely autonomous and the human is in an override situation in a kind of a global sense, you can get by with opaque algorithms. But on the other hand, if you have humans that has to intervene in the machine processes, then you need to have a transparent system, which means that the system has to be able to articulate where it is so that the human can intervene in a meaningful sense. And the point being that sometimes you may have to sacrifice algorithmic performance to maximize joint human system performance. And I think that's a fundamentally important point here. That we are really looking at the combined performance of the human-machine system, not the performance of each in isolation. And that's a mistake we often make. And the final thing I would like to say is that engineers have come to change their perception now, which is they used to view humans as incomplete, inefficient processors that needed to be compensated for and shored up. So they were viewed as a liability. And the designs never capitalized the human's ingenuity to get out of a jam. That is changing now. People are looking at humans from both a liability and an asset perspective and trying to design systems that minimize the occurrence of exceeding their limitations while exploiting their capabilities. So I think these are some of the things that are going on, and in our courses at USC, we make it a point to really work through examples to show this thing in a very, very real sense.
I'm kind of reminded by in the ESA environment how humans interacting with each other in terms of that it's collaborative across all these nations with obviously very different cultures and languages and everything. You know, what have you found to be successful in terms of keeping humans effectively in the loop as ground systems evolve? Any thoughts on that, Nestor?
Well, first of all, ESA is the confirmation that 25 nations can work together and with a common goal. Mm-hmm. And is one of the best examples of what Europe wants to be. Of course, from the engineering point of view. With respect to human in the loop, we need to consider the human as well, not working on a system and operating a system, but the human in the organization. And if you compare with other industries where automation is far ahead of us, like the car industry, the syndicates were reluctant to the introduction of robots in the production line. And we can see, or we have seen this type of effects, but now the people has started to understand that what is needed is more on a supervisory aspect on the operations, and that the routine type of operations can be done automatically. Still, we are in a point where if something happens, the human goes into the loop. We are not at a level of automation that the system responds automatically in case of some failures. Because for that, you need models, you need some type of rule-based systems or artificial intelligence, and then is the dispute how I can trust a model and not my skills to operate a satellite. So we are in the middle of this transition. I believe automations will still go ahead. Just for the aspect of unit testing, integration testing, validation, verification testing, we are achieving a level of continuous integration and validation, test automation that 20 years ago was a dream. 20 years ago, we were running with paper and with our hands how the system can be tested. Today, this has achieved a level of automation that took the human out of the loop, and we can run this during the night. So these type of things have progressed very good. Others, we still need to see. The talk this morning and with the morning speaker has shown which are the challenges for the future for the operators. And we are, as JPL, in the same type of situation for the future.
Thank you. So we've heard a lot when people have been talking about commonality and advancement in areas of tasking and anomaly resolution for ground systems. This question asks, what is your organization doing to advance the other areas that also, of course, very important related to ground systems, which would be mission processing, exploitation, and dissemination. So that whole, once you've got the data and now you've ingested it, and you start talking to that a little bit, Steve, maybe you could talk a little bit more about that in terms of future trends, thinking about mission processing, exploitation, and dissemination.
Sure, we've actually focused on that quite a bit over the last few months. So our focus has been, we have a number of interests, but probably one of the biggest ones, being in an operational agency on the civil side, is finding ways to be more efficient, more effective. And so we took a pretty good look at where some of our costs come from, and it turns out that things like creating and then integrating algorithms, right, to produce new products is an area where we didn't give it a lot of focus early on. We do quite a number of new products each year, every year. Frequently they're for things that couldn't have been conceived when we first started. And so we're looking at automating that. We're looking at going to standard development environments, building development environments that accurately mimic the operational environment. So when you get the algorithm working, it's pretty straightforward to transition it. And we've had quite a bit of success working with our primes, actually, helping make the whole process much more effective for us. And likewise on the exploitation side, looking at how we can harness IT to do pieces of it more and more effectively. So in our architecture work, as we looked at migrating to common services, one of the insights we had early on was that the more similar the functions are for the different missions, the more they lend themselves to being done in a common sort of way. So now we have an archive that's archiving all the satellite data, and we're actually looking at a new version of that that's going to leverage cloud much more heavily. So it's more effective, and it also costs less to maintain. We're looking at, we have a partial centralized distribution capability, and we're looking at moving everything onto that. And now looking at the level 2s and maybe even the level 1s, but certainly the level 2s where you've already got the basic products from the sensors formed, and you're looking at combining them to provide more complex sets of insights. That's just basic processing, ones and zeros. It doesn't have anything to do at that point with the particular hardware design of the instrument that it actually came from. It's just applying an algorithm. So we're looking hard at how much of that can be pulled out of maybe a very proprietary design, or a design that required specialized hardware because of the way it was conceived years and years ago. And how do we move that into a modern environment that can take advantage of the new technologies, whether it be Hadoop or any of the other things that you may have out there. And I think there's a commercial model for that too. A couple of years ago, we were watching Skybox and how they were evolving. So unlike some of the other earlier companies that were launching imaging satellites to take pictures that they would then sell, Skybox's model was an IT Silicon Valley model where they would store the data. They would sell you the picture if you wanted it, or the video, but the goal was to store the data and to make access to the data available. So you would bring in an algorithm to run to extract information on specific behaviors or features that were embedded in the data. So it was much more of an IT-centric play rather than a pictures from space play. So we're looking hard at how we can apply those different approaches.
I'd like to ask Colonel Bracy, because obviously in working with your partners on enterprise ground, associated, like for example, trying to line EGS with the NRO Enterprise Ground, which has a lot to do with mission processing, exploitation, and dissemination. Any thoughts there in terms of how to do that successfully? I mean, obviously, it could be very disruptive to be able to try to think about doing that.
If you're talking about the PED stuff, I mean, really
Yeah.
what we need to do as far as the IC and the folks that do the
Right,
big data is
right.
we need to listen. What have you done? What things have you gone through? And not repeat the mistakes that they had, or at least the lessons that they had. How do I take whatever they've done well
Yeah.
and do that? Right now, I
Right.
think we're working a different part of the problem
Right.
because we're more concerned on the operator side of it,
Right,
different ways they
right,
operate.
yeah.
But they're very concerned with how the amount of data that comes off
Yes.
their systems is dramatically
Yes.
more than the DoD's.
Yes, yes.
We're picking that up, but let's just
Yes.
use what they've
Yeah,
got.
yeah.
That creates it means we have to have the collaboration with them and sit down
Right.
and talk with them and figure out who's going to go after that to understand
Right.
what those documents look like, who the people are, the right people to talk to, et cetera.
Right, I mean, your point is they really do excel on that, so to,
Yeah, that's their
listen
sweet
and
spot.
find
I don't
out.
need to
Yeah,
do their
right,
sweet spot
right.
for them. They've got
point.
that. All right.
Yeah, thank you. Very good point. Any other thoughts related to the question related to the kind of back end, Stig? Anything, thoughts about dissemination? You probably have to disseminate information to a lot of different sources as far as any things that are innovative or trends that you're seeing in terms of doing that better?
Yeah, no, I think it's just like to underline what's been said here. It's I think the IT industry and like you said, Silicon Valley approach is definitely ingesting into the satellite industry. From our perspective, we're really agnostic in that approach because we're just a information service provider to the satellite, really. So, but we're seeing more and more of this approach, moving different processing levels into the cloud, of course, and yeah, we're trying to, of course, see, where does that bring us in terms of nodes and architectural design. But I think it's really intriguing, and I think it's adapting best practice from multiple industries is really the way to go. I think we've seen, the mix of either short or long runs in terms of modulation types and also processing from IT industry. So yeah, it's truly interesting and be really fun to see where we're at in
Where
a
we're
couple of
going.
years, I think.
Well, I would like to segue in a couple questions related to our theme, which is kind of over the new horizon, looking to the future. And so, as we talk about developing common ground architectures, standards for mission critical systems, what do you think is kind of if you would mention one technical challenge or risk that we're not talking about here, but we should be, and if that involves some kind of a challenge to the community here in terms of what you see is needed to move us all forward from a community standpoint, what would that be? So is there some risks you're seeing we're not talking about, maybe the gorilla in the room or whatever, what would that be? And is there anything that you would say is kind of a challenge that all of us need to do to be more successful in terms of looking over the horizon? So anybody want to start with that? Nestor? Yeah.
Yes, it has been presented during this week in some of the presentations, and today has been as well addressed. One of the biggest challenges that we have for the future is data collection from the future satellites and the big data on the ground and data analytics. The other challenge that we have is scalability in both directions. When you have a system that works for a big mission, you think how can be used for multi-mission, how can be used for a constellation, but now we are obliged to think in the other direction. How can I use my system in a more simple way for nanosats, for small missions, CubeSats, and for constellations of formation flying of this type of satellites? This is a challenge that before we have never thought about. We have always thought from us in the direction to big constellations. Now is a new challenge, and we are working on that, we are studying that, but we are not yet there to offer our infrastructure to any type of satellites. We believe that this could be available in the next years.
How about for EGS, the
I think
technical
the
risk or
girl in the room,
challenge?
and we haven't talked too much just because of the orientation of this conference, is cyber.
Well,
All right, how do I ensure if all the data that's coming down, how do I ensure I have data integrity?
Right.
And we're talking about, General James said, what, 3 petabytes of data? I mean, that's a phenomenal amount of data. And I think he actually said something about diddling with this data.
Right,
All right,
right.
well, you know, how do you ensure that that data that you're using, okay, is actually correct from the authenticated source, that no one has tried to do something with that particular data? That's something we all face, no matter what. It's nice to have the assumption that everything is an uncontested environment and all of our stuff is here for the freedom of humanity, et cetera. But people see different ways to use that against us, okay,
Right.
whether ESA, any of those.
Right.
So that requires time and money and technical know-how to build those in from the start to ensure that is the right data that's coming down that people are then acting on.
Right, right. And we did have a working group yesterday on that topic, and we'll hear an outbrief related to that, but they had some commercial providers in and got some, I think, great ideas related to that in terms of, we are all experiencing that. So yeah, very, very good point. Definitely a big risk. Any other thoughts on challenge or risk, Steve?
Sure. I think one of the biggest risks, it's not a technical risk, and it's the willingness to move to new business models, because that's very, very disruptive in some ways. So an example is open source. Open source does require maintenance, just like any other kind of software, but it doesn't carry the large licensing fees. And by its nature, most people, I think, would say that it's more secure than the proprietary stuff, because more people put their eyes on it. When there's a problem, it's fixed much more rapidly than it might be by one of your traditional software houses. So going to that, changes revenue streams. The way that you maintain it going into the future may also make some changes. And I know from experience that when you try to make major changes in business approaches, people do push back, and they push back at multiple different levels. So I think having the wherewithal to get the support to actually make some of these concepts real is a genuine risk.
Good. Dr. Mani, in terms of what you're seeing in some of the research related to resilient systems, any key technical challenges you're seeing there? Obviously, we all would like to make our systems more resilient, especially related to the cyber asset, but other aspects as well, too, just to have them more robust.
So resilience is one of those terms that's not very well defined, and the only time you can make sense out of it is when you pick a particular domain and make sense of it in that domain. And I think with respect to the space domain, there is a very good work that has gone on at Caltech, at the Keck Institute of Space Studies. I was part of that team. And we define resilience specifically for space and space operations. That said, I think the important thing is that anytime you're trying to build a system with some specific non-functional requirements in mind, like resilience or survivability and things of that nature, or security, have to do it as part of the architecting process. It cannot come in at the tail end as a patch. The system has to be architected with those non-functional requirements in mind. There's no other way to get around it. So therefore, when we teach our courses at USC, we don't just teach how to build resilient systems. We talk about how do you build resilient cybersecure systems, because you want to upfront acknowledge that cybersecurity has to be addressed at the same time that you're addressing system resilience. You cannot bring it after the fact. And I think that's the most important thing that I would say with regard to that question.
All right, very good. Well, we're going to be wrapping up in about 10 minutes, but I did have one last question I'd like everyone to address. And again, it's related to our theme of looking what's next over the horizon and looking to the future. And so obviously innovation is occurring all around us. As Mr. Steve Asakwood said yesterday, change is the new norm. And so and we talked a lot about it being change management in terms of accepting that change in innovation. But if you could cite, one thing that you see as a trend or a future direction that you think is, the most hopeful as far as impact to ground systems and looking to the future ground systems and architecture, what would be that one thing that you kind of see out there on the horizon, looking at the horizon, that would be a future direction that you feel could really help us in all of our goals for ground systems? And I'm going to start at the end, and I'm going to come back this way and leave the final word for Colonel Bracey. So, Stig.
Yeah, it's always hard to predict the future,
Yeah,
right? So, no, I think for sure it's going to be higher throughput capabilities. We're already started with K-band and looking in and beyond. We're looking at other higher frequency band or even optical communication. I think in terms of platforms and accessibility will be changed. I think we've just started, like mentioned here, to work with different business plans and to emphasize the mission. And I think that's going to be a big game changer. So I think agileness and flexible approaches is the key here, and that's where we see probably a lot of the development coming ahead of us.
Thanks. Steve.
I would say probably the biggest thing is somewhat of a transformation in the role of our systems. If you look into the past, they were satellite control and data processing, right? And the goal was to control the satellite and process the data. I think in the future, you're going to see IT systems or IT engines that take in data from a variety of sources, some of which are satellites, but by no means only satellites. And the outputs are going to be not just data processed from satellites, but products that span a broad set of applications built on a broad set of inputs. So we're going to become IT engines rather than satellite control systems.
Interesting. Nestor.
In Europe, we have cycles of 20-25 years to change our infrastructure to be used for any mission. And we are in this cycle since 5 years. So in the next 3-4 years, and this is our main task, looking to the horizon, not beyond, because we need to have the system verified and validated by end of next year, because the new telecommunication platform in Europe that is called Neosat, the two main manufacturers that are Airbus and Thales Alenia, needs to adapt their infrastructure for the EGSE, that is the electrical ground support equipment, to test the satellite on ground. And then ESA will use this system for the mission to Jupiter, JUICE, with launch in 2022. So our main efforts are dedicated to that. Looking beyond the horizon, of course, as Steve said, we are looking in new IT engines and technologies to solve some of our problems on big data, problems on cyber, and so on. But we are at the start of this renewal of infrastructure, and we are concentrated in that because we cannot fail. The systems that we have today in Europe are obsolete, are C and C++ with object-oriented technology developed in the late 80s. Our new engineers are saying this is a stone age. And we have systems that are being operated with the old technology today that was developed in the 70s. So it's nice to look beyond the horizon, but we have to deal with the day-to-day problems for the next 4 or 5 years.
That's good point. Thank you. Zahn.
So what I'd like to talk about is when there are these very sexy terms like agility and resilience and things like that, and we almost believe that we can do without it. And but then some reason asserts itself, especially in places like Aerospace Corporation and JPL, where they talk about affordability as being an important thing. So many years ago, I wrote a paper on affordable resilience. But what I'd like to say, it's really not an all or nothing game. You can't say that this system is resilient and this is not, because that absolutely means nothing. You can say that this system is resilient in dimension X. That's all you can say. And it may not be resilient in dimension Y, because we know that introducing a particular quality attribute, such as resilience or agility in a particular dimension, will come at the cost of sacrificing something else that's important. And I think that the two concepts that I think will become very, very important as going into the future is the concept of trade-offs, and how we trade off these different desirable attributes so that we come at some point where we have something we can afford and something that gives us the flexibility to work with the unexpected and adapt to the disruptions as we go forward. And so I think that that's going to be the key thing. And mathematically speaking, for those of you that speak that language, we may have to back off of being on the Pareto frontier, so that when you back off of that, it gives your buying or purchasing flexibility to be able to address solutions at other points on that frontier, and not optimize for a particular point solution, because in a dynamic environment, what's optimal this moment may not be optimal the next moment. So I think our whole way of thinking about optimality has to change, and I think we have to think in terms of trade-offs, and we have to recognize that every single attribute, resilience, survivability, agility, etc., they come at a cost. There is no free lunch. And only buy those things when you need them, because otherwise you're squandering resources for no good reason.
Colonel Bracy.
So I see it as we move forward, at least in the Air Force Space Command in particular, multi-domain operations is hot right now, which is how do we break our data down to fundamental pieces, identify those standards and interfaces, get down to like microservices. That data is available that someone can exploit in ways you never thought before. And that's air, that's space, that's cyberspace. How do you bring that data together and understand it? The commercial equivalent kind of internet of internets. How do I have those seamless barriers where machine-to-machine interface happens autonomously behind? You don't need to do that. I kind of consider it very kind of the standing on the shoulders of giants. If you look at Kepler's and Newton's laws, okay? I'll tell you what, I could not derive those laws way back then. Not a chance. But now, today, when I get taught them, I can understand how to use and apply those. So the challenge isn't for me to essentially derive those equations, it's to do what next with those equations. So as we continue to progress forward, I don't need to go back to the basics. I need to essentially go, I got the basics now, how do I continue to evolve on that, break things down that then are seamless that everybody can use moving forward, and now see what people can do with it.
Very good, thank you. Well, I want to thank all of our panelists. I want to thank everyone for their questions. I know we had some questions we didn't get to, and also some maybe very specific questions. Our panelists will be up here for a few minutes if you want to, come up and chat with them or grab them I don't know, do we have a break now or coming up?
Yes, we'll be taking a break,
So they could talk to them
and we'll be
then?
back at 11.
Okay, so you have time to come up, ask your questions when you take the break, but please join me in thanking all of our panelists for this very insightful discussion.
And thank you, Marilee, for moderating our panel. Please return at 11 o'clock. We'll be doing the summaries for the
might wanna read
working
that one
groups from
because I didn't
yesterday
ask it 'cause it was very
to hear
specific,
from
but you might-
the chairs,
It's
and
interesting to know
also the
what people are
summary for
thinking out
GSAW.
there, related to EGS.